Hello, my name is Roland Dreyer. I'm a technical specialist at Autodesk Media Entertainment in Europe. Here's version 2 of my compound pack Procedural Polygon Generation for Bifrost. The goal of these compounds is to create a construction history in Bifrost that uses simple initial objects, simple blocks of a few polygons, to create complex buildings that automatically adjust to the scale. The concept for this kind of modeling was presented by my colleague Maxime Jean-Mougin at the GDC 2022 as a Platinum Games employee, and he referred to earlier work by Akira Saito. The concept of PPG is best explained by this simple building. A simple polygonal block from Maya is gradually subdivided further and further in Bifrost. First horizontally into building segments, later into floors, rows of windows, ledges, etc., some of which have static dimensions, while others react flexibly to changes in size of the building. This is followed by the horizontal subdivision into windows, apartments, units, balconies, etc. The horizontal subdivision can also react to changes in size by scaling and re-subdividing. Individual elements of the facade are then brought out or put back using the extrude function, and further elements of the building can also be modeled. Finally, part of the facade is then replaced by more complex pre-modeled elements where procedural modeling would be too time-consuming. In a final step, materials for rendering can be assigned to the collections of surfaces shown here in color. Once this construction history is set up, this recipe works without further human interaction and can be applied to other simple input objects, which it will turn into the same kind of building. The resulting Bifrost graph, the construction history, can become quite big. It is a long sequence of operations on the polygonal object. But these recipes can also be collapsed, even nested, to form a much simpler function block with just a few important settings that anyone can use to create buildings from simple blocks. Now let's have a look at a more complex example for PPG for the procedural polygon generation. As you can see in these renderings here, this looks a lot better, even though it's fully procedural. There are barely any instances or pre-modeled elements in here, and there are not so many elements there. It looks very complex. It looks like in all apartments there's something different going on, but this is simply an effect of randomization. So what we basically have here are some balconies. The whole facade was built from a simple plain polygon, and the whole building isn't much more than a cube, than a polygon cube. Now let's have a look at the wireframe here, and it doesn't look as good anymore. So here we have different views of the wireframe, and you can clearly see, yeah, there's not much there. We have these chairs here. That is clearly an instance. But apart from that, the whole thing is not very complex. So you see that all the apartments that are inside the building here are mainly empty. There are some lights created automatically and randomly distributed in the buildings, but there's no furniture, there's no people in there, so the apartments are mainly empty. It still looks very complex, the whole building, in the rendering. We also see that these balconies are loggias. Actually, it goes inside the building behind this concrete balustrade. So the whole loggia is enclosed in concrete here. And then we have a glass element, and then we have some handrails in white here that simulate a proper balcony. There is a chance that there's a chair in there. We have different sizes of these balconies. So this is a very small one here, very small version. Then there's a next bigger version over here, and that is, I think, the biggest one. Or do we have a bigger one even there? I don't know. I think this is the biggest one here, the one with 4 supports on the handrail. That is the biggest one. Then we have a glass door or windows behind the loggia and a curtain behind it. And all of these curtains, even though there are different versions of the curtain, but you see the curtains are scaled a little bit. They are placed on the left and the right or in the middle. So there's quite some variation going on, and it's all automatic. And we have these other apartments here that are simply just a window with a room behind it. And I could still, place some furniture inside these rooms. Now when I zoom out, you see that the whole thing is really simple. It's made from a simple cube. And then the middle section of the building was extruded outwards to build this front facade here, and the sides were then turned into single balconies with a glass front for the apartments behind them. I can switch this whole thing transparent now, and we have a look at the inside, and you see inside there's not much going on. All of these apartments are coming from the front. So what's inside the building is just, a square room to simulate some space that's inside. To simulate that you can look inside. There's some rooms inside, but there's not much going on except at the moment for these lights that are placed randomly. There's not much there. And the thing that is still fascinating is that I can select the cube that was originally building or that was the source for this whole thing. And I can scale the cube, even though it's not very fast. But you see that it rebuilds itself. So when I scale the original cube very small, we only then have a few balconies left here and a little bit of the facade. But still, when I click on render, you will still see that the whole thing looks like the original building and looks like the original object that we had there. And I should, turn off the grid here so that we have a better look at it. So it's still completely procedural. It does everything that the large building does as well. And this is a great way to, pre-visualize concepts for architectural facades, for example, instead of building them, in different sizes all by yourself. Okay, now let's reset this whole thing and maybe turn off the transparency. And I want to guide you through the first steps and show you, starting from a simple cube, to start to segment the building into the pieces that we need to insert these apartments and these balconies here. So here on the side I have the Bifrost graph editor. You see the whole construction history of this building so far. It's pretty big. So it doesn't even fit, when you see the nodes, it doesn't even fit on the screen. But as I said, you can collapse part of this construction history by simply building compounds, by simply grouping these things together. So let's go to the very beginning, and we just take the first node, the input node, which is the basic cube that we had at the very beginning, and I detach that, or actually I'm going to take the first two because that saves me at least one step. And I zoom out a bit and I take those two and move them to the side and create another output node, because that's where I want to start from. And now you see already the initial cube. So that is the Maya cube is hidden in my scene, and that is the thing that shows up as soon as I connect this whole thing to the output. There's one more thing missing, that is a PPG diagnostics node. That is something that you will always need when you do this or when you construct with PPG, because it shows you in colors and actually written on the faces, on the surface, the face tags. So what I do here with this first node, that is a select faces by normal node, which lets me define a normal. So in this case, it's the positive z-axis, and then selects all the faces that point in this direction. So the goal is to have exactly this angle here, so there's no plus or minus, and there's not a large tolerance. So when you increase the tolerance, for example, there will be a point when the side faces are also selected, because it's over 90 degrees, the tolerance. But this way we have, the front face selected. The next step would be to cut this front face into 3 parts, and there's a node that does that actually all the time. So that is probably one of the nodes that you will need the most. It's the multicut node, PPG multicut. So, and one of the first things that you have to do is to, in the tag expressions, to say which faces you want to cut, which faces you want to select for this multicut. And by default, it's an expression that's not a valid name for a tag. When I remove the brackets and just add an S here and hit return, then you see the first face gets subdivided multiple times, and there's a red arrow shown here, and that is a principle of PPG. So you select faces to work on, and then you do something on that. And in most cases, in many cases, you also have an edge selection together with the face selection. So these two sections belong together. The faces can be either an expression or an array of face indices that you plug in here. It doesn't show up in the inputs. And this edge selection is a method to select edges for each individual selected face. So for each individual selected face, in this default here, it goes from the center and goes along this direction vector downwards in this case, and picks the first edge that it finds. That's this one here, that's the ground edge. It's, by chance, it's also the first edge in the polygon, so the index 0 for the points would be over here. But it is important to know, so when I pick this cube that builds this initial cube, and I rotate the cube by more than 45 degrees, you will see that, pop, suddenly the selected edge changes because this downward vector now points at this edge here, and that's why the edge changes. So why is this edge so important? Well, because that is the one that we are subdividing. So when this is horizontal, we get vertical cuts. So that's why I'm saying this is divided horizontally. It's a horizontal edge. This red arrow can be turned on and off by this terminal switch here. It's just a diagnostic feedback to show you which one you have selected and why your faces do it like that. So when I scale the cube now up and down, you see that it keeps re-subdividing itself. And one of these two pieces here, I think it's the blue one in this case, it seems to be flexible. Look, it changes the size. Yeah, of course, if you want a number of subdivisions, one of the pieces needs to be flexible. Otherwise, the last one could be flexible, but one of them needs to be flexible. And in order to be symmetric, I made one of them flexible. That's what you set in the next settings here. Flexible is the inner part. So the inner part are the ones that are enclosed in the green ones here. So the blue ones are the inner part, and that's the flexible part. You can make them both flexible or none. But look what happens when none of them is flexible. The last one needs to be flexible. And then next time there's enough space for a new subdivision, pop, here's your new subdivision, and the last one is the only flexible one. It's not very fancy. Sometimes you need that, but both is a choice that makes more sense. Both are flexible. But usually, when you want to have windows of fixed sizes, then you would set the outer flexible so that, the blue ones keep the same size always. So the windows would not change, their size would not be scaled when you instance windows in these blue spaces here. So that is the principle of PPG multicut. There are also cut settings. I have an extra tutorial for multicut, so you can look that up. So let's scale the cube a little bit larger, and we wanted to segment the whole thing into 3 cuts. So the easiest way, instead of saying I want to change the sizes here of inner and outer, the easiest way is to say we just make one subdivision. There's one outer, an inner, and one outer. Now, inner is flexible at the moment and can change in size, which is not so bad. So we just readjust the size of the outer to get these balconies that we have seen at the beginning. Well, great. And we can give them names. So currently, when you look at the names, it inherits the parent name, which was selected faces, and then adds an outer and an inner to it. That's here. Inherit source tags, outer and inner. I can turn this off, inherit source tags, because at the moment it's so simple, the whole thing. The outer would be the sides, maybe, and the inner would be the main, for example. Right? So that's our first basic subdivision. Now we can turn off the diagnostic feedback of the PPG and go on. So we want to extrude the main now out. Take this one here. And when you have this option selected to connect nodes on creation, then it's possible to select the wire and then simply create the node PPG extrude, and it will be put in the wire immediately. It takes a second longer, but it's more convenient, so it's easier to do it that way. So here again, this game, we have a face selection. We say we want to use the main face, which is this one here in the middle, and it gets extruded out. And you can adjust how deep you want that. There's also an offset, but in this case, it doesn't make any sense. So we make this simple cut here. And We can say, okay, this main part here can inherit the names, but we can also say the face is still the main face, and the sides here, we're not going to do anything with the sides, so they remain the same, and we can start giving them material numbers like concrete. Right, so from now on these sides will be concrete, and anything else where I know I'm not going to subdivide it again, and it will be concrete, I'm going to call it concrete. I'm simply going to call it by its material name, and we will later assign these materials for rendering in Maya. So now we need to subdivide this main piece and also the sides, because the balconies will have the same subdivisions, or should have the same subdivisions. They have the same floor height as the main block here. So we're gonna make a subdivision again. It's at the moment we are still segmenting only the building. We have a huge concrete strip at the top and at the bottom, and that's the next thing that I will create here. So let's do this and keep shifting this one here. There's also a settings, by the way, here, shift on connect. So every time I include a new node, the other nodes need to be shifted away. So when I put these closer here, these two, and I include a node here, you will see that it gets shifted away. So it would be a PPG multicut node to cut off the strips at the top and at the bottom. And now you see, it shifts the rest away and selects it also. It's a bit dangerous when you hit delete immediately after you created the node, but this is for moving the graph around so that you don't have to do it manually all the time. So what's our task here? We want to select not only the main face to cut it vertically. So at the moment we need to do a next edge. So this one here gets subdivided, but we want to subdivide this one here to get horizontal cuts. So we do a next edge. We actually do a +1, look. So now the red arrow points in this direction. Oh, that's good. So now we actually only want to have one subdivision, and the outer size actually, oh yeah, we can scale that and say this is going to be my concrete part here at the top and at the bottom. I'm not going to inherit names. Oh, I will inherit names. Now look, what I forgot to do is to pick the sides here. So the sides need to be subdivided as well. I can simply add the name to this expression here, sides, and they will be subdivided as well. They also get a red arrow as an indicator for the selected edge, because that's done for each individual face. For each face that you select, and I picked 3 of them here at the moment, and now we have this one here. So inner means that's the main part here. I would say this one is main, and the outer one is concrete. So these also are now counted as concrete pieces, and the main ones need one more subdivision, because now what I'm going to do is to say I'm going to cut this whole thing into strips, and the apartments that you see here in the middle, in the main part, will have a concrete balcony, and then the apartment behind it, behind this balcony. And there's, each strip will then be a concrete balcony and the apartment. But here at the end, we need an extra strip of concrete to make this whole thing symmetrical, because it starts with a concrete strip and ends with nothing. So we need to go with the main here, either before we do it or after after this one here. We need to do this one again and to say PPG MC. I'm using the shortcuts here to create this, and now we can use all the main ones, all the ones that end with main here. So I can use a wildcard and main as a selection. So you see that all of these are picked here already, and we need a vertical edge, a subdivision only at the end, and this is here the settings for the mode. We don't want the outer on both sides, we want it only on the end side, and that's at the top here with one subdivision, and we can adjust the outer size here. So that's my outer size. I can readjust it later when I see my balconies have a certain height. I can readjust this thing here. And again, we have this, we have this name problem here, that inner and outer have a certain namespace. Okay, so the inner would be my main. Again, we have 3 mains here, and the outer would be, again, my concrete. You see that the names become quite long. I can now make a session and simply rename everything that is concrete to concrete, and also rename the main and the sides again to make the whole thing easier. There is a node called rename face tags here that you can use in a row to say, for example, when I use the main to give this one a new name, sorry. And then the other one would be, so rename face tag, it's this one here. And the other one would be sides main to rename them to sides. Okay, so that makes it easier for us. We could also make a new face tag for everything that is called concrete, but we will have more things that are called concrete. So we leave it at the moment and use only these 2 face tags. So the next step here would be another subdivision horizontally. And this time we need a simple subdivision, a simple, we don't need 2 pieces, or we don't need an even number of pieces. And there's only, with multicup, there's only a way to say I want either start and the middle, or end and the middle, or start plus end, but I have to tell up front how many pieces one segment would be. There's no way to say we want just 1 and 1 and 1 and 1, and if there's more space, add 1 more. So this possibility we don't have in the multicut, and that's why we use the PPG sequence cut here. Sequence cut is a strange thing, and I can already say here I want the main and the sides. Oops, forgot an I. The main and the sides, and you see what sequence cut does here. It has a preset of sizes, which are relative sizes: 1 unit, 2 unit, 3 units, 4 units, 5 units, and you see that's what it does. It cuts the thing into these strips of various thicknesses, and for the sides it can only the 1 and the 2, and there's not much space, no more space there. So what we want to do here, you see that face selection and edge selection is the same as with multicut. What we want to do here is to pick the next edge because we want a horizontal cut, and then say this is all nonsense, I just want a 1, but I want to repeat this 1 in a loop. And suddenly it does all these unified cuts here, which is very cool because they're all the same. I can now use the scale sequence to scale these cuts up and down. And now when the cube is scaled vertically, we can actually try it out here with the scale tool. You see that it re-subdivides the floors by itself. So the floors have a little bit flexibility to, be able to compensate for this moment before there's space for a new subdivision, and this flexibility is needed, but they do exactly what we need them to do here. I make them a little bit bigger, maybe like that, right? So, and we can call them whatever we want. We call them sides 1, for example, or sides floor, or whatever you want. So this 1 comes from this one here. There's a number of names from 1 to 10, which it will only use when there are up to 10 different sizes here in the sequence. So this sequence is a very cool way to do all kinds of irregular subdivisions if you need them. And in this case, it's definitely what we want. So the next one again would be, and now I'm just working on the middle portion of the whole thing. The next one will be multi-cut again. So, and we say this is gonna be main 1, main underscore 1. We want vertical cuts again, so I do it vertically. And now I just want one subdivision, and it should be the start that I want. So that will be the smaller size. So the outer size need to be smaller here. So I need to, I just one subdivision. What did I click here? I clicked something. So I just need one subdivision. The outer size needs to be smaller. That's our balcony now. And I can turn on off all of these diagnostic feedbacks. Okay, so the main one outer is now my concrete again. And it stays like that, it will be concrete. And the inner one, that is my window for the apartments, or I can call it A because I'm gonna work with that in the next step and divide it horizontally. So I'm not gonna touch the outer ones, or I could touch the outer ones, I think. Not sure about that one. Yeah, we can do the sides as well. But that's not concrete. The sides are not concrete. So maybe I will copy this size here later, maybe 0.5 or something like that. Maybe I will copy that later over because we need a similar subdivision here, but we also need a subdivision for the balcony. So that might be a little bit more complicated. But in the last step, or in the step, for subdivision, when we talk about this main thing here, what we need to do now is to segment the whole thing horizontally and to define where is there a piece of just a window, where's the loggia, and what size is it? We have different sizes here. And what I did in the original recipe here was to use these sequence cuts here. And maybe I copy one of those and paste it into my own recipe. So I want to subdivide number A. So let's put it in, and let's put this one in here, and the name of the whole thing is A. And you see, oh yeah, it subdivides the whole floor into these irregular segments here. So we have the size 1, the size 4, the size 1, the size 4. And these are, these are concrete pieces here. So what I call C here is a piece of concrete. So it starts with a piece of concrete. Then there's a window. It's I call it the right window, RW. And then there's a piece of concrete. Then there's a B, which is a balcony of size 4 in this case. Then two concretes, concrete. And then there's another balcony with a size of 3, and so on and so on. So this is the subdivision that I want to give the whole thing. Now, what's with the scaling? So it says to repeat it as a loop. So when it ends, it simply starts over from the beginning. We could also say, let's bounce it. So it bounces in the middle here, for example, and then goes backwards. Oh, that's cool. So now when I go and scale my cube underneath, not only vertically it will repeat all these stories, but horizontally it will repeat this pattern. It will bounce this pattern. Here's the bouncing point. No, it's not the bouncing point. It must be somewhere here. There's the bouncing point, and it simply reverses it and repeats it again on the other side. Which still does not solve the problem with, it's all the same floor. I could, of course, use another sequence cut or something to say, hey, I'm cutting it, but I'm giving different names. But that wouldn't be procedural, because once you scale it, it could become higher and higher and exceed the number of definitions that you have made. So that's not gonna help us here. So let me detach this thing here. So we are back in this unsubdivided state here, and I'm picking something else from this thing here, and that's these nodes here. So I'm copying all of it, and I will explain it because building it live is a little bit too tedious. So let's cut these connections here, and let me show you what I'm doing here. So I'll move these over and move this one over, and I will put this in the chain. So what I'm doing here is to use a get face info node, and we actually want to use the A here because that's all the one that we have. And this gives me information about these facets. It's all an array because, the pivot position, for example, what's the pivot for this facet? The face ID, what's the face ID of this facet? Because later maybe I want to do something with it. And what's the face center? You know, I can use that to group these things together. And there's a node for that. So that's why I use the face center here. And let me do that with the y-axis here. So I'm feeding the face position in and split it up into the component and say I just need the y component. And then I need this node here, the cluster values, to say depending on the y position of these faces, I'm building groups. And it outputs groups here. So this is a two-dimensional array. It says, okay, the group number 1 has the face 1, 2, and 3, and the group number 2 is 3, 4, and 5, and so on. And then I use this node pattern rename to give them new names. And when I plug this back in here, object connection missing here, of course we need the same connection to this one as well. So, and then when I do this here, you see that it names them floor A, B, C, D, E, and then starts over at A. That's no grouping. It's probably because the tolerance of this one here, so there's a tolerance of 0.3, that's too small. We need to make that bigger to make bigger groups here. Now you see we have 2 floors A, 2 floors B, 2 C's, and 1 D. And I bet when I zoom out a little bit and scale my cube up, it will, you know, repeat the D floor and then the E floor 2 times and then the A 2 times again. So here we are at the A again. That's not so bad. So why did I have this random array in here? Yeah, because it's a little bit boring to have 2 of this one, 2 of that one, 2 of that one. So I plugged in a random array and set the tolerance very small, 0.3, you remember. So we get more random groups of this. So it creates random numbers, and that's actually not bad because now I have, you know, 2 of these groups, the 2 A's here above each other, separated by a B and surrounded by a C. That's not so bad. I like that one. So let's keep the random clustering here. Then I put in my sequence. Actually, you can hold the Alt key and point at the connection when you drag one of these nodes, and it asks you what to connect here. Also a little bit easier. And then I say, okay, the new names we have here are floor A, for example, and then it replaces these with the new recipe for the horizontal subdivision. And of course the sizes, I can still scale the sizes, you know, if I want to have larger apartments here with the sequence scale, I can scale the whole thing out and have a different kind of subdivision. This looks nice and symmetrical to me, so it's very cool. And I can then, you know, change the names here. You know what? I can even say I don't want to inherit any tags. I simply leave these apartment names here because later my apartments will be replaced exactly in these names. And I don't need to make more complex names. Now I can copy more of these sequence cuts into this chain here. Let's pick another one, or maybe all 3 already, and put them in. So like this, go closer, connect it here, and then connect it to the output, and we will see, wow, we have these connections everywhere. I just need to, because I changed the size here to the sequence scale to, let's say, 0.3, I should do it everywhere else too, 0.3, so that the apartments and the concrete strips in between all have the same sizes. Of course, I could make a floor with different sizes, but it looks a little bit creepy. It needs to be a little bit more. And I would also turn off all of these inherit source tags, because the floor, which floor it is, actually doesn't bother me anymore. I can now say, hey, this is my apartment. And look, it has a nice pattern to it. It's really beautiful. Wow, that's cool. So that's the basis for my apartment, or for my building here, for the great grand facade with all of the apartments. And in the next step, we will have a look at how the apartments and the windows are built. How do I build a loggia with a balcony and a handrail and windows and curtains behind the windows? We'll do the curtains a little bit later, but let's have a first look at how to make an apartment. When we have a closer look at the main facade, we see that both of the balconies or the loggias, as well as just the apartments that are just windows, start from a single rectangular polygon. So we can make it simple and just create a rectangular polygon, maybe together with this balcony part here, with this concrete balcony part. So we create one of these rectangular polygons, then construct our loggia or just a window apartment, and then apply these rules to these polygons that we have here by just telling the name. So all the B's will be turned into a balcony or a loggia. So let's have a look at that. This is now the finished loggia apartment here, and I set my viewport so that I can look inside the polygons. So polygons are visible only from their front side. From the back side they become invisible. That's how I can look into this apartment. And you see how the loggia is built. So we come from this concrete strip here and the rectangular polygon, and then from there we extrude inside the apartment. And the problem here, or this is a minor problem here, the one issue that we have here when I come from this continuing concrete strip here, I only have this part of the loggia to extrude in. And then we need to go somehow down here. That's why we have this lower section of the whole apartment, because I was extruding this down here. So I was taking the floor and extruding down both loggia and apartment itself. And the biggest problem there was that this window plane here needs to be scaled or modified again. I did not want to extrude it because then I would have an extra edge in the middle of this polygon, which does not allow me to do this continuous glass surface here. So that was one extra step. So let's have a look at how this is built. So we actually start with a single polygon like this one here. I started with a B, which is the balcony or the face tag for balconies. And imagine this concrete strip would be continuous. That is one of the challenges that I had in this project. So with this continuous concrete strip, I want to construct the apartment behind this. So the continuous concrete would be part of the loggia, which makes it a bit complicated to construct the apartment downwards from here. So we take this B face tag in such an extrude operation, and when I turn this on here, you see the name is B. When I turn this on, okay, this would extrude in -1 direction, so in the negative direction. And what I'm doing here is to not start the loggia right away, but to have a small, the balcony first, the balcony rail or part of the balcony rail. That is this one here. That's why I call this one still concrete. From here, we extrude the apartment inwards, which is another extrude operation. So the apartment face will now be extruded inwards. And this is the actual loggia. So with this one here, I adjust how deep the loggia will go and my balcony, so to say, and space for chairs and so. And the back side here of the loggia, that is the source for my window of the apartment. And the problem is to get this window down to the floor, because we are not extruding downwards yet. We would get this edge here in the middle of this window, which does not help at all. So instead, what I'm doing next here is to copy this glass. So to copy the wind source as my glass. It's a chip off operation, but you can also do it with a new extrude that allows you to make just a chip off instead of extruding. So when I make this one here, we have two faces here in the same place. And with the second one, with a glass source, I would do a transform. PPG transform allows me to say, I want to pick the selected edges, which would the downwards edge of this glass source face here. And I want to move it in minus or in negative direction. I want to translate it in negative direction. You see what happens here? So now I have, with the PPG transform, I can set this glass as high as my apartment would later be. And I could now, of course, extrude backwards from here, from this main source, but that would raise another problem now with this floor here of the loggia. So instead, I'm taking wind source again, and extrude again. So wind source will again be extruded, and that's my apartment now. So now I scale it backwards to say this is the room for my apartment. I can make it as big as I like, and will later extrude both floors downwards and get rid of this wall here in the middle. My glass in the meanwhile stays there, and this wind source that we had here that we used to extrude the apartment, was deleted. So here the source face mode is set to delete, so it removes this source face, and my glass is still here. So now we are using a select faces by normal for both the loggia and the actual apartment. We are looking downwards, so actually we select all the faces that point upwards and feed those faces directly into the next extrude, which would be this one here, which extrudes them down. And here I set the same extrude depth like in the transform. Let me look it up. So let's say minus 1.8 or so, and I can actually do a node, set a node that sets these values for both of them equally, so that I can adjust the apartment floor to my liking. It should be a little bit less than the balcony because the next apartment starts right underneath. Okay, so we have this glass source here now. Now we can use a multi-cut node to take the glass source and cut it vertically, so that we have 3 panels here. And I made them both flexible. You can of course say only the inner one is flexible, and we have the outer ones as fixed elements for the glass here. Or we can say the inner one is a door and it always has the same size. So that's why I set it to both, because I did not know what to do here. But just to make sure, you know, if you want to have glass elements that always have the same size, that would be the way to go. And in the next multi-cut operation, I would also again cut the outer panels horizontally. So that's this one here. So here we have a cut, and you see already at this moment I can say, okay, both of them are named glass. I don't need to make you know, extra names here, inherit names anymore, because this one is all going to be glass. The middle one keeps its name because we needed to address the outer ones. We had to have different names. And now in the next step I can extrude the glass. So I'm taking all the glass pieces here, and they are set transparent already because for better view here. So I'm taking all these glass elements and extruding them to get these frames here for the glass. And you are free here to use as many operations as you like to get proper window frames. This is just an example here of how you would make this glass element. And in final steps now, I would create a handrail here. So what is needed for the loggia to receive a handrail is we create a polygon planar object right inside Bifrost. So within here, I'm using create mesh plane, this node here, to create a polygon plane. And you see I've wired it up to set the height of this glass handrail, and move this thing up and scale it accordingly. Right, so I'm picking now the top face here of this concrete. I'm picking this one long face and use a PPG instance node to place my glass handrail. And with this wiring that I made here, I now have a chance to define how high this must be. So it's moved up by the full, so it's scaled by the full height and moved upwards by half of it. That's this wiring here. That's why. So it's still a little bit programming. You see that we need to think about math here to make this, to automate this. In the next step, so that was my first instance to place the glass here. In the next step, I would take a little cube that I create here inside Bifrost and place this cube on top of the glass. So I'm selecting the glass plane again and say, okay, one of these edges here. So I want to place this cube and stretch it out completely. So there is different modes for stretching here. That's a 1-axis stretch. And here under pivot, you would see, okay, pivot is the ones that are selected. Now the vector is pointing upwards here, and I set it to the middle of this edge here, of the top edge. And the last step finally would be another extrude with mesh cubes that I place vertically on the glass. And these are also wired together with this value that we have here to, you know, be scalable, so that I can now adjust the handrail and all of these pieces will adjust accordingly. The next step would be to create a curtain. In my whole construction history, I should have a point here where I copy the glass again to act as a source for the curtain later, because I can use an instance node to place the curtain, to scale it accordingly, and to move it, shift it randomly left and right so that it stays inside this area, but, you know, is randomly scaled in the width and moved to the sides or somewhere on this glass operation. So that's how you would create one of these apartments. And the other element, the apartment without a loggia, is even simpler. We have to do this step here to extrude the apartment downwards, but you don't have this glass element here in the middle that you need to transform to get a continuous glass. So it's a little bit less work, but it works similar to this one here. So let's have a final look at the result here, now that we know how it's built. And you see here on the right side, you see the whole construction history. I'm going to collapse the graph editor too, so that we have a better view here. So this is one view with a zoom. Actually, the camera is set to a larger focal length, and here I have a view with a little bit more wide angle, where we see, you know, with a wide angle we can look a little bit inside these loggias here, and you see the curtain, for example, the construction of the curtain. You can see that very clearly, how the curtain is placed. I only have like 4 different versions of the same curtain with a few points moved, so that the curtains don't look uniform all, and then they are scaled horizontally and placed horizontally inside this window room. You can see that's very well here. So this curtain is scaled very, very small horizontally and then placed in the middle somehow randomly. So that was my project PPG 2.0, the release of the new set of nodes that you can use to construct architectural detail like this one here.